Hey everybody, it's hwsteele and today is January 13th, 2020. It's already the 13th day. We're almost in the middle of January already. This is incredible how fast time flies. Well, today in this video I want to talk about the sunrise, or more specifically the time of day of the sunrise. I took this picture months and months ago now, but I still love it. I love the clouds, the way the clouds look in this picture. But I digress. I want to talk about the time of day the sunrise happens. Now, we can actually go to the Astrolog the Astrolog program and look at the ascendant and the sun and determine the approximate time that the sun will rise. And you'll notice that I have this set to June 9th, 1906, which might be a familiar date to you. And I have Astrolog set to 5:10 a.m. on June 9th, 1906, because that's approximately when the sun was at the same longitude as the ascendant. The ascendant, well, let me turn on the house system here. This will make it a lot easier. To do that, you just go to settings, you go to house system, we'll turn on the Placidius house system. And here we see that we have the first house, second house, all the way around to the 12th house here. And we have the sun at approximately the same longitude as the first house, as close as you can get within 1 minute. Now, if you'll notice, this is the midheaven right here. This is the ascendant, the midheaven, and the descendant right there. And we have more than 90 degrees between the ascendant and the midheaven, and the reason for that is because in June the days are longer, at least in the northern hemisphere. It's not the actual day that's longer, it's the amount of sunlight during the day that is longer, because the longest day of the year, of course, is the summer solstice, June 20th, and then the shortest day of the year is in December, of course, but right now we're focusing on this. Now, there's something that a lot of people don't realize about the longest and shortest day of the year. And I'll get to that in a second. But first, I just wanted to point out here that the houses are all skewed. They're not equal because of how long the day is and how long it takes to go from the ascendant to the midheaven. Now, something I want to point out very quickly, that the word forenoon, F-O-R-E, noon, actually means the morning time. It's any time between when the sun is at the ascendant and at the midheaven. In other words, it's morning time. It's not necessarily the hour right before noon, but it's any time in the morning. So that might be important to you, perhaps. Maybe, maybe not. Anyway, moving on. So if I move through the day here, I'm going to set this to move a couple minutes at a time. We can see that as the sun rises, the size of the houses change. And then when the sun gets to the midheaven, it's approximately, we're at about 90 degrees right here for each quadrant of the zodiac. So the houses are almost equal sized right there. And then as the sun starts to go down, we start to see the 7th, 8th, and 9th house enlarge and get bigger. And again, this is happening because in June, there's more sunlight, right? In other words, the sun spends more time above the horizon than it spends below the horizon, especially the further up we go in latitude. And we can see here that in Texarkana, which is what I have this set for, we're at about 33 degrees north latitude, so we're definitely going to notice the sun being above the horizon for more than 12 hours at this point in time. So, let's see, there we go. So, right here we see the sun at 5:10 a.m. is at the ascendant. So essentially we're getting sunrise, and this is on June 9th. But I'm going to do something here. I'm going to change Astrolog settings so that we change one day at a time. So it's going to go to June 10th at 5:10 a.m., then June 11th, and so forth and so on. Now I want you to watch the sun and the ascendant here. As we go forward in time, we see that they kind of stay together for a while, and then the sun starts to drop below what would essentially be the horizon. It's dropping below the ascendant. Now the reason for that is as we go further into the year, the days are getting shorter and sunrise happens later and later. So at 5:10 a.m., which was the time of sunrise on June 9th, the sun's actually below the horizon by a few degrees, and it will continue to, as the year goes on, it will continue to get further and further below the horizon. We can just watch that happen here at the 5:10 a.m. And of course, we all know why that's happening, right? It's because the length of the daylight is different each day of the year because of the tilt of the Earth. So now we're back. Let's see, we're at June 26th right there. Let's go back to June 9th at 5:07. Now, here's the thing that you might find interesting here. The shortest day of the year, of course, is the summer solstice, the longest day of the year, which is June 20th. But what you might not realize, let me pull up a little chart here, is that the earliest sunrise does not happen on June 20th. This is 2018, June 20th, set for Texarkana. This site, unfortunately, which is timeanddate.com, doesn't go all the way back to 1906. I can't get the year back that far. So I can use this year, and it's going to be approximately the same. And what we see here is that the sunrise gets earlier and earlier, and then right here on June 10th, it's as early as it's going to get with the precision of 1 minute. And then it stays the same, and then the sunrise actually starts to get later and later before the summer solstice. But if you'll notice, the sunset, which is getting later and later here, because the day is getting longer and longer, it continues to get later, even though the sunrise is starting to become later itself. So the sunset actually continues to get later up until the early part of July. So essentially, if you average out the day that in July where the sun sets the latest and the day in June where the sun rises the earliest, you're going to get the summer solstice point approximately. So even though the summer solstice has to do with the declination or the tilt of the Earth, and so does the earliest sunrise and latest sunset, they don't all happen at the same time. They're 3 different points in time. So the last day that we get a noticeable change, we click from 6:06 a.m. to 6:05 a.m. is right there at June 9th and 10th. And that happens every year, with the exception of a leap year where it's off by 1 day. So I just wanted to point that out to you because you might take that as important for some reason. So let's go back to Astrolog here. So if we look at this again, and I go back in time before June, we can see that the sun was below the horizon at 5:10 a.m. Then as we get closer to that date, the sun comes up to the point where it hits the ascendant at 5:10 a.m. and it never goes above it, and then it starts to go below it. And that's showing us graphically here that that's the earliest sunrise right there. And one other thing I wanted to point out really quickly is that if you live somewhere other than Texarkana, you're going to have different times of day, obviously, for the sunrise and sunset. And the obviously the latitude of where you live is going to have an effect on that, how long your day is, that kind of thing. Like in New York City, the day is actually going to be a little bit longer. You'll have a little bit more sunlight. You probably have Sunrise would probably be, I don't know how much earlier, but a few minutes at the very least. Off the top of my head, I don't know. So anyway, my point here is that in the very early part of June, we see the sunrise not being any earlier. It stops, and then it starts to get later and later. And then we have the later June date of the summer solstice, and then we have the early July date of the point in time where the sunsets start to get earlier again. And then the days just continue to shrink and shrink. And it doesn't really matter where you are, that the dates are going to stay the same, that we start to have, or that we stop having earlier and earlier sunrises. But the number of days that it takes for the for the time of day to start increasing. Let me pull this back up. So for instance, we have in June, I'll explain this a little bit better here. In June, we have 1, 2, 3, 4, 5 days here where the sunrise happens at approximately 6:05. But if I were to actually go to, let's see, I'll set it to New York. And then we'll go to June. Where are we at? 2018 right here. We see that the sunrise gets earlier and earlier till the 8th right here. And then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 days where the sunrise happens within the same minute of precision. There's actually obviously a few seconds difference here. So anyway, that's just something I wanted to point out to you. And typically they're going to tell you that the earliest sunrise happens on like June 14th. But the precision by which, or the amount of time you allow difference, if you keep it to 1 minute, then it starts happening dependent upon where you are around the 8th, 9th, and 10th of June. And then the sunset, the latest sunset happens in early July. See, we have 8:31, July 1st was the latest one. So anyway, that while it seems like it wouldn't be all that important, there are certain things that you can do with this, or certain, how should I say it, certain paths that you can take with this that can become very interesting to follow, I think. But I'm not really going to go into any more detail, because if this is something that interests you, you'll probably be able to find your way quite easily. Whereas if this is something that you find completely boring and useless, then obviously you're not going to waste your time with it, because you'll consider it a waste of time. So anyway, until next time, this is hwsteele, and I will talk to you in the next video.